All right, the last lesson in chapter 4 is about scientific notation. Okay? First, let's talk about when is scientific notation used? What is the point of this lesson? Like, what is it? Yeah, so where in science?
The math part.
Well, not exactly. Can you be specific about anything?
Like if you're saying how many bears are hibernating this winter and you like use math and science.
Chemistry.
Okay, it might be. How many bears would we estimate there are?
Trillions. Billions.
Billions of bears?
I like that.
The bears.
Do you think there's more bears or more people in the world?
Yes.
Bears.
Bears.
Yes.
Yes.
Are there like cities of bears?
Yeah. It's called Narnia.
Alright. We're on the right track. There might be, I don't know, 100,000 bears in the world. Maybe 1 million bears. Okay. There are less bears than people, for sure.
Yep.
Okay, there's about 7 billion people in the world, I think.
It's actually 7.2, but you know.
Yeah. So,
I checked the radar.
if you were to write this number, let's take Jacob's estimation. Alright? 7.2 billion people in the world. You can write this number in scientific notation. Alright? Scientific notation is used to write really, really big numbers. And really, really small numbers. Okay? It's used to take this number and write it as a power of 10. Because our number system is in base 10, meaning that each time you move to the right or to the left in a place value, it's either 10 times bigger or 10 times smaller. So the ones place is 10 to the 0 power. And the tens place is 10 to the first power. And the hundreds place is 10 to the second power. We already know that about exponents, right? So, scientific notation is written so that the first number that's written is between 1 and 10. So we would take this 7.2, which are the non-zero digits, and write that as the first number in scientific notation. Okay? And then we would write the rest of the number as a power of 10. So what would we multiply 7.2 by to get 7.2 billion? 10 to the 7th power. So if we count the places from the far right of the number, since this is a whole number, all the way to where we would put the decimal point to get 7.2, there are actually, how many places? 3, 6, 9 places, right? From here to here is 9 places. So wherever you're putting the decimal point in the actual number, that determines how many places the decimal needs to move in order to multiply this to get to the original number. Everything to the right of the decimal is the power of 10 that you would use. Okay? And you always put the decimal point after the first non-zero digit. So after the 7. And that gives us a number. The first number must be between 1 and 10, right? That's what it says in your notes. You already took these notes. That the first number in scientific notation must be between 1 and 10. So you can't write 72 as your first number in scientific notation. It's not between 1 and 10. You also can't write 0.72 0.72. Because 0.72 is less than 1. It's not between 1 and 10. Okay? Are you with me on that? You understand? Thumbs up if you know. You put the decimal point after the first non-zero number. Okay? You need to stand up. Then, let's go back to our notes. You put times 10, you always write times 10, and then you count the places after the first non-zero digit. So, in this case, 8,600,000 would be written 8.6 times 10, and then there are 6 places behind the non-zero digits. So we write 10 to the 6th power. Okay? Now, you also can use scientific notation to write really, really small numbers. Let me give you an example of that. So, we have 42 thousandths. How would you write that as a decimal? 42 thousandths. .042. Yep. 42 thousandths. This is tenths, hundredths, thousandths. Okay? Now, once we have it written in decimal form, we can write it into scientific notation. The first number has to be between 1 and 10, so where would we put the decimal point? Between the 4 and the 2. Yep. So you'd write 4.2. Okay? Now, you have to count the places that you'd have to move the decimal point to that spot. How many places in the number would you move the decimal place to get it to that spot? 2 places to the right. Instead of moving the decimal place to the left with a really big number, when you're translating a really small number, you're moving it to the right. So you write times 10, and it's a negative exponent. Yep. 4.2 times 10 to the negative 2nd power. Okay? Now, how would you put this in your calculator to check it? Type in 4.2, everyone. And then times 10. And then the caret button. And then negative 2 equals. Got it? Yep. 0.042. Okay. Now, like I said, scientists use really, really big numbers. Like, they've measured all of the different variables that contribute to the Earth in order for it to be able to sustain life. And they've measured all these factors. In other words, like the fact that our planet is mostly water, that it has the amount of nitrogen to breathe, it has all of these things that allow life to exist in our world. And those factors are about the chances of that happening without divine intervention, in other words, without God putting those things here, would be like one chance in 10 to the 150th power. Okay? So we can see that that is a scientific notation, right? Instead of writing 150 zeros behind the 1, yeah, yep. What?
I didn't. Nothing.
Or you can write about, there's a number in chemistry.
Einsteinium.
10 to the
It's a number.
23rd power.
See, W is a
It's a
number.
really, really big number. That's
The Illuminati.
it's the,
You check
What's
the
that
commercial.
sense?
It's showing me the light. Showing me the light. I know
a
everything.
mole in chemistry is like,
More.
yeah, no, that's a different kind of thing. All right, let's go to your assignment. Oh, wait, one more thing.
Moly, moly.
To multiply numbers in scientific notation. Okay?
That part.
So what if you had 1.6 times 10 to the 6th power
Like this is
times
bigger than
3.7 times 10 to the 4th power? You can use math to do this. Okay? You can use the concepts that we've used. So, because these are all multiplication, we can switch the order, right? Using what? The commutative property. So we could do 1.6 times 3.7. And then times 10 to the
6 plus 4.
good. The 6 plus 4 power, which is 10 to the 10th power. Because these have the same base, we can add the exponents. So then do this on your calculator. 1.6 times 3.7 times 10, and then the caret button, 10 equals. And what is it?
5.92 times 10 to the 10th.
Do you agree with him, Katie? Yeah. 5.92 times 10 to the 10th power. Okay, that's a lot easier than doing 1.6 times 10 to the 6th and then putting that back into standard notation and then multiplying it times this in standard notation and then putting it back into scientific notation. We can use maths to do it. Okay?
2 plus 2 is 4.
Now, go to your assignments.
I don't know.
Page 223. We're going to do 1 through...
7.
Wait, no. We're going to do 2 through 20, 2 through 30 even.
Might be seen.
No, 2 to 32 evens. 2 to 32 evens. On page 223. Okay?
What?
Wait, what is it?
Look at number 32.
2 to 32 evens.